Dear students, welcome back to a new mathematics session. In the previous session, we have discussed question number 11 to 20 from exercise 9.5. In today's session, we shall discuss the remaining problems from the same exercise. Let's move on to the topic. We shall discuss question number 21. Find four numbers forming a geometric progression in which the third term is greater than the first term by 9 and the second term is greater than the fourth term by 18. First of all, let's write the given statements. In mathematical statement form we have to write, okay? So here, when we go through the statement, four numbers forming a geometric progression, it is asked to find out four numbers. These four numbers forms are a part of a geometric progression in which the third term is greater, here it is, the third term is greater than the first term by 9. So the third term means T3 is greater than the first term means T1 by 9, that means plus 9. This is what the statement. And the second term is greater than the fourth term by 18. Second term means T2. Second term is greater than the fourth term means T4. Fourth term by 18, T4 plus 18. So this is what the mathematical statements which is given to us. Now let the four numbers in GP are A, AR, AR square and AR cube. The four numbers we have assumed. Then as per the given condition, T3 plus T1 is on the right side. When we bring to the left side, it comes as minus T1. So T3 minus T1 is equal to 9. Then T3 we know that it is third term AR square minus T1 is A, first term. AR square minus A is equal to 9. In these two terms, there is A is common. When you take A common outside, R square minus 1 is equal to 9. Then label it as equation number 1. Now the second statement, T2 minus T4, you see here T2, this T4 we can bring to the left side, means T2 minus T4 equal to 18. That is written. T2 means the second term AR, T4 means fourth term AR cube. So AR minus AR cube is equal to 18. Then from these two, the higher degree term we can write first. AR cube minus AR means just taking a minus common, means that minus we are keeping it on the right side, that is minus 18. That is what we have done, is just or you also can say dividing through minus sign, minus 1. That means wherever minus is there, all becomes plus. Here minus AR cube is there, plus AR cube, plus AR is there, minus AR, plus 18, minus 18, dividing through minus, that is also can be done. These two terms again, AR is common. When we take R square minus 1 equal to minus 18. That is equation number 2. Then 2 and 1 we can divide it. Here A into R square minus 1 divided by AR into R square minus 1 equal to, here it is 9 divided by minus 18. So when we check the common terms in the numerator and denominator, there is A is common, we can cancel it. R square minus 1 we can cancel it. Then 9 and 18 also we can do 1 by 2. So 1 by R, here numerator nothing is there, 1 balance divided by denominator R is there equal to, here 9 and 18, okay, we'll just divide that also. 1 time 18 means here we'll be having 2 times, so minus 1 by 2. Then R is equal to, R into 1, R is equal to 1 into minus 2, minus 2. So putting in 1, when we put this one in 1, you will get the value of A. That is A into R square. R square is minus 2 the whole square. Minus 2 the whole square is 4. 4 minus 1 equal to 9. That is 4 minus 1 is 3. 3A is equal to 9. A is equal to 9 by 3. 9 by 3 is 3 we will get. So the 4 terms of GPR. You see there, these are our assumption. A, first one is A. A is 3. It's written. Then AR. AR means 3 into minus 2. 3 into minus 2 is minus 6. AR square. AR square means 3 into R square is 4 here. 3 into 4 is 12. AR cube means A is 3, R cube is minus 2, the whole cube is minus 8. So 8 into 3 is 24, minus 24. So these are the 4 terms of GP. Next we shall discuss the 22nd question. If the pth, qth and rth terms of a GP are A, B and C respectively, prove that A power Q minus R into B power R minus C into C power P minus Q is equal to 1. Pth, qth and rth terms are A, B and C. Then we have to prove this statement. let A be the first term and R be the common ratio, because here A, B, C smaller letters here we have taken in the question itself. So it's better to take the capital letters, capital A and capital R. Then AP, that means the pth term. Pth term means AP, we can say AP is A. Then if pth term is A means, if it is nth term means we know that it is AR power n minus 1. Here it is pth term means AR power P minus 1. Here A and R we have to give bigger letters. That is what our assumption is equal to A. Next qth term. Qth term is B. That means AR power Q minus 1 is equal to B. Next is rth term, that is C, means AR power R minus 1 is equal to C. Then this is what we have to calculate. A power Q minus R into B power R minus P into C power P minus Q. You see here A, B, C all are here with us. So only the powers we have to fill it. That means A, what is A? AR power P minus 1. So AR power P minus 1 power Q minus R that we put into B. B is AR power Q minus 1, that is written AR power Q minus 1 power R minus P, that is written into C. C is AR power R minus 1 power P minus Q, that is written. Then we have to remove the bracket. So this is one bracket is there, power Q minus R. So each term power is Q minus R. First term is A power Q minus R. Second term R power P minus 1 into Q minus R. Here also same thing, A power R minus P, R power Q minus 1 into R minus P. Here also A power P minus Q, R power R minus 1 into P minus Q. Then these A's, all A's we can collect together. Base same means the powers we have to add. You know the rule. Base, here you see A, here also A is there, here also A is there. So powers we have to add. Here Q minus R plus R minus P plus P minus Q. See here it is written. Into here also R, here also R. That means we have to add the powers. While adding time, just there are two brackets, so we will remove the bracket also. Same time we will do simultaneously. P into Q, PQ, P into R minus PR, minus 1 into Q, minus into minus plus R, it is written. So this bracket is over. We are coming to this bracket. That means Q into R, QR. Q into P minus PQ, minus 1 into R, minus into minus plus 1 into P is P. Then this bracket, R into P, PR. Then here R into Q, that is minus QR, minus 1 into P, that is minus P, minus into minus plus Q. Now you see the cancellation is possible or not. Here plus Q, minus Q we can cancel. Minus R plus R minus P plus P completely gone. Then here you can see plus PQ, then here minus PQ, minus PR means plus PR is here, minus Q means plus Q is here, then plus R minus R is here, then plus QR minus QR plus P minus P completely gone. There is not a single term balance. That means A power 0 into R power 0. A power 0 is 1, R power 0 also 1, 1 into 1 is 1. So that is what we have to prove, that is what our RHS, hence the proof. Next we shall discuss the 23rd question. If the first and the nth term of a GP are A and B respectively, then if P is the product of n terms, then prove that P square is equal to AB the whole power n. First and the nth term of a GP are A and B. First term is A, nth term is B. If P is the product of n terms, prove that P square is equal to AB the whole power n. This is what the question. A be the first term of GP and R be the common ratio of GP. First term of course it is given to us also A. So common ratio R. So first term of GP it is A, it is given to us. Nth term of GP we know that it is formula AR power n minus 1. That means as per the given condition B is our nth term. That means B is equal to AR power n minus 1. Label it as equation number 1. P is the product of n terms is given to us. P is the product of n terms means A1, A2, A3 etc. up to AN. That is when we put the terms here, A1 means first term, A, second term means A2, A2 is AR, third term means AR square, fourth term is AR cube into etc. Nth term we know AR power n minus 1. Then here From all these terms, a we can take out a into a into a into a, etc. up to a. Then here first term there is r is here. So r into, the next is r square into r cube into etc. power r power n minus 1. First term r is not there, but of course it is a product, it's not an issue. So from here onwards only we are taking r into r square into r cube into etc. into r power n minus 1. Here a into a into a etc. n times is there. That means a power n. Then here are powers we are adding. Since the bases are same, powers we can add 1 plus 2 plus etc. plus n minus 1 powers. Then here we know that 1 plus 2 plus 3 plus etc. sum of first n natural numbers. In AP we have studied. You can just by heart this one as a formula. That is sum of first n natural number formula is n into n plus 1 by 2. Very easily we can calculate sum of first n natural numbers, n into n plus 1 by 2. Now here you can see 1 plus 2 plus etc. plus n minus 1 terms. That means 1 plus 2 plus 3 plus etc. plus n minus 1 means sum of first n minus 1. Here you see the last term n. Let's say here n into n plus 1 by 2. Here the last term is n minus 1. Means this n you have to replace, put n minus 1. So n minus 1, again n replace and put n minus 1 plus 1 divided by 2. That is here minus 1 plus 1 you can cancel in the second bracket. So minus 1 plus 1 if you cancel, in that bracket we are having only n balance, n into n minus 1 divided by 2. This is what we are going to write here. You see this 1 plus 2 plus etc. plus n minus 1, that is this term n into n minus 1 by 2. So a power n same, r power n into n minus 1 by 2. Then we are asked to find out p square. So p square we can calculate here. P is this term. P square means just square it. That means a power n into r power n into n minus 1 by 2 the whole square. Separate it. A power n into 2 into r power n into n minus 1 divided by 2 into 2. Here there is 2 we can cancel in the numerator and denominator. These two we can cancel. That means we'll be getting this a power 2n into r power n into n minus 1. So a power 2n, from there n is there, from these two terms also n is there common. Okay, so n keeping separately outside the bracket as power, that means power n. Here a square, here r power n minus 1, the whole power n. So a square r power n minus 1, the whole power n. What we have done is from these two terms n we took outside and kept as a common power. Then this a square we can write it as a into a power r power n minus 1, the whole power n. Now when you see here a r power n minus 1, a r power n minus 1, we know that it is b. That means a into a r power n minus 1. This we can group it. Okay, it's not necessary to group also. Here itself we can substitute, but just to make it pair for understanding purpose. A r power n minus 1, the whole power n. That means, as I said before, a r power n minus 1 is b. So a into b, the whole power n. That is what our RHS, a into b the whole power n. P square equal to a into b the whole power n. Hence the proof. Next we shall discuss the 24th question. Show that the ratio of the sum of first n terms of a GP to the sum of terms from n plus 1 to 2 n the term is 1 by 2 r power n. Ratio means numerator and denominator is there. The numerator is sum of n terms. Denominator is sum of terms from n plus 1 to 2 n the term. Here first part we will check sum of n terms. Sum of n term means Sn is equal to a into 1 minus r power n by 1 minus r. Formula only, equation number 1 we can keep. And the next part when you check, it is telling about sum of terms from n plus 1 to 2n. That how do we calculate? Sum of terms from n plus 1 to 2n the term. That we can write like this. Okay, there is from first term is there, first term to we are having up to n the term is one group. Okay, n the term. Then soon after n the term, that means the next term of n the term is n plus 1 the term. N plus 1 the term to next group I am taking 2n the term. Okay, this is the last one for us, 2n the term. So this group I am making first term to n the term, then after n the term we have n plus 1 the term to 2n the term. Okay, then here sum of n plus 1 to 2n the term, n plus 1 to 2n the term in this portion I will mark it. So that portion means from here to here we have to find out this sum only actually we want. This sum how do we calculate? We are going to calculate from the total sum. From the total sum means we know that total sum means from first to till the 2nth term. From the total, if we are subtracting the first group means this group, first term to nth term. Okay, from the total, if you are removing this portion first to nth, we will be having nth to 2nth sum. Means once again I will tell you, first to 2n the total we will be taking. From that total, if you remove first to nth, we will be getting this total. That is what I am going to write. Sum from first to 2nth term, first to 2nth term minus sum to first to nth term. Then we will be getting n plus 1 to 2nth term. Okay. Then sum of first 2n term means we can write it as first 2n terms minus sum of first to nth term means first n terms. Then 2n formula means s2n minus sum of n terms means sn. Means here in 2n, if you want, just replace n, put 2n. So a into 1 minus r power 2n by 1 minus r minus a into 1 minus r power n by 1 minus r. Sn and s2n we have substituted. Then a by 1 minus r is common in both. We take a minus 1, a by 1 minus r. Then 1 minus r power 2n minus 1 minus r power n. And here when you check, there is 1 and minus 1 we can cancel. Plus 1 and minus 1 we can cancel. Then we will be having a by 1 minus r into here. Minus into minus plus r power n is there. Then minus r power 2n. Then sum of n terms by sum of terms from n plus 1 to 2n the term. This ratio only we want to calculate. Sum of n terms means this one. So a into 1 minus r power n by 1 minus r. Here a by 1 minus r into r power n minus r power 2n. Then here in the denominator a by 1 minus r, I am just taking common. Here also a by 1 minus r is here. So a by 1 minus r into r power n also I am taking common. Okay, r power n going out means from here r power n going means 1 balance. Here r power 2n, r power 2n means r power n into r power n. That's why r power 2n is coming. Powers we are adding, n plus n is 2n. From there 1 r power n is outside. That means 1 more r power n is inside. Then a into 1 minus r power n by 1 minus r. This a by 1 minus r we can take inside. Then the r power n just to keep outside first. R power n into a into 1 minus r power n by 1 minus r. I can check numerator and denominator. Together we can cancel this complete term. So that is gone. So the balance is 1 divided by r power n. This is what we have to prove. So hence the proof. Next we shall discuss question number 25. If a, b, c and d are in GP, show that a square plus b square plus c square into b square plus c square plus d square equal to ab plus bc plus cd the whole square. Here 4 terms are given to us in a GP, a, b, c and d. These 4 terms are in GP. So ar square, ar cube, etc. are in GP. This is the general form of a GP. Then given that this is our general form, but it is in the question, it is given a, b, c, d are in GP. So a, this first term is equal to here the first term, that is equal to a. B is equal to the second term, that is equal to ar. And c and d respectively ar square and ar cube. Then a square plus b square plus c square into b square plus c square plus d square. That is what our LHS. So let's substitute the values of a, b, c and d here. So a square means a itself, its square, a square. Then b square means a r the whole square means a square r square. Then c is a r square, its square, c square we need to take. That means a square r power 4 will be coming, it's written, into b square. B is a r, its square is a square r square. Then c square is a square r power 4. Then d square means here a square r power 6 will be coming, r cube the whole square, that means r power 6. So a square r power 6. Okay, then here in this term there is a square. This first bracket completely a square is common is there, so we can take outside. Then 1 plus here r square balance, here r power 4 balance, into in the second bracket if you check, there is a square r square is balance common everywhere. So a square r square if you take outside, in the first term 1 balance, second term a square is outside, r square is outside. So 1 r square balance it's written. Here a square is outside, from r power 6 r square is outside means r power 4 is balance. Then here a square here a square. So total a square and a square is a power 4. Then here there is an a square. Bring it to first. Then 1 plus r square plus r power 4. Here also 1 plus r square plus r power 4. Two products means it will be coming as square. Same term products will be coming as square. Label it as equation number 1. Then right hand side, if you take AB plus BC plus CD the whole square. For that AB plus BC plus CD we can substitute here. It means A, B, C and D respectively. A first term is A itself. B is AR. It is written plus B is AR into C is AR square. Then C again, that is AR square. D is AR cube the whole square. A into A is A square into R. Then A into A is A square. R into R is R cube. A into A is A square. R square into R cube is R power 5 the whole square. Then in these three terms, when you check a square r, here also a square r common, here also a square r common. Take out common factor a square r. The first term 1 balance. Here a square is out, r is outside. Means r square is balance. Here a square is out, r is out. That means a square completely gone. R power 5, r square, r going out means r power 4 balance the whole square. Then here a square r the whole square means a square the whole square. A square the whole square is a power 4. Then r square, it is outside, into 1 plus r square plus r power 4 the whole square. When you check this is equation number 1. When we compare it with equation number 1 and equation number 2, both are same. So from 1 and 2 we have LHS equal to RHS. That means the given statement is proved. Next we shall discuss question number 26. Insert two numbers between 3 and 81 so that the resulting sequence is GP. So two numbers between 3 and 81. Here the first number means first term is 3 and the last term is 81. Between these two numbers only we have to put or insert two numbers. So the resulting sequence is an AP. Means when we put two numbers in between these two, there will be 4 numbers. These 4 numbers forms a GP. That is what the question. We know that to insert n numbers between A and B, common ratio R is equal to B by A the whole power n 1 by n plus 1. So please by heart this formula. Common ratio, in order to insert n numbers between A and B, the common ratio R will be B by A the whole power 1 by n plus 1. So here A is equal to our first term, that is equal to 3, and B the last term, that is 81. So B by A values we can put from here. That means R is equal to B is 81 divided by 3 the whole power 1 divided by n plus 1. 1 divided by n plus 1 means 1 divided by n. N is here we are asked to insert two numbers. So 2 plus 1. 1 divided by 2 plus 1. So that is 81 by 3. When we cancel, we will be getting 27. 27 power 1 by 3 will be coming. 27 power 1 by 3 means it is cube root of 27. That is the way we can write. Or else this 27 we can write as 3 cube. Both are correct only. 27 power 1 by 3 directly we can write as 3 because cube root of 27. Or else 27 we can write as 3 power 1 by 3. Then into 1 by 3 is there. So that 3 we can cancel. Here 1 3, here 1 3 we can cancel. The balance is 3. Then we have got the common ratio is 3. The first number means AR, not A. Okay, first number is A into R. A into R means our A is 3 and our R is 3 again. So 3 into 3, that is equal to 9. Then the second number is AR square. So AR square, if you put A is 3 into R square is 3 square. So 3 into 9. 3 into 9 is 27. So the two numbers, the required numbers are 9 and 27. So here you need to remember this formula. R is equal to B by A the whole power 1 by n plus 1. And again here also you must note first number means after 3. Which are the numbers we are going to write? We are going to write two numbers. That will be the second and third number. Okay, second and third number in order. But when we write here, this is our required first number. That means in the GP that is the second number. So AR. And here second number means in the GP that is the third number. Okay, that is why AR square it is written. So these are the things you need to keep in mind while solving this question. Next we shall discuss question number 27. Find the value of n so that a power n plus 1 plus b power n plus 1 by a power n plus b power n may be the geometric mean between A and B. So this one is given to us, the geometric mean between A and B. So here we know that the geometric mean between A and B is a root of AB. So this is what the geometric mean when we discuss. Geometry between two numbers a and b is root of ab. So here root of AB, the geometry mean between two numbers by formula we know root of AB. According to our question, it is given to us this one, a power n plus 1 plus b power n plus 1 by a power n plus b power n. Then here AB, root of AB we can write it as AB power 1 by 2 equal to right side is same. Then here what we can do is just cross multiply it. Cross multiplying time, a power n plus 1 in plus b power n plus 1, here denominator 1. So 1 into a power n plus 1 plus b power n plus 1 is a power n plus 1 plus b power n plus 1, the same quantity. Here we can split a power 1 by 2 into b power 1 by 2. So a power 1 by 2 into b power 1 by 2 into a power n plus b power n. Cross multiplication we have completed. Then a power n plus 1 plus b power n plus 1 is equal to, here a power 1 by 2 and here a power n. Okay, so when we are multiplying means we are removing the bracket. Okay, this quantity into this one. So here base same quantities a power 1 by 2 and a power n. Together when we write a power n plus 1 by 2 and here b power 1 by 2 balance that we have written. What we are doing is we are just removing the bracket. Removing the bracket means the base same components powers we have to add 1 by 2 plus n, that is what it is written, into b power 1 by 2. And this quantity into the second quantity if you multiply, here b only is there, b power 1 by 2, b power n. So their powers we have to add n plus 1 by 2, that is written, into into a power 1 by 2. Then here a power n plus 1 minus a power n plus 1 by 2 b power 1 by 2 means this quantity we are taking to the left side. Okay, a power n plus 1, then here a power n plus 1 by 2 plus b power 1 by 2, this term we are bringing to the left side, it comes as minus. And the right side there is a power 1 by 2 b power n plus 1 by 2 is there, and from the left side minus b power n plus 1 means this plus b power n plus 1 moves to the right side, it comes as minus. Then here a power n plus 1 is equal to a power 1 by 2 plus 1 by 2 we can write. It means this 1 we can split as 1 by 2 plus 1 by 2. That is what it is written. A power n plus 1 we can split as a power n. This 1 we can split as half plus half. Then this again we can split, means a power n plus 2 as one quantity. Then this plus power 1 by 2 what we have to do is we have to put a base here into a power 1 by 2. So when we multiply these two powers we have to add the n power plus 1 by 2 plus 1 by 2, that is what it is written here. What we have done is just we have split it. So b power n plus 1 also same way we can do it. B power n plus this 1 we will split as 1 by 2 plus 1 by 2. Then as before this way we can write, that means b power n plus 1 by 2 into b power 1 by 2, that we have to write here. Then here a power, this one we are splitting as a power 1 by 2 into a power 1 by 2. So a power n plus 1 by 2 into a power 1 by 2, the same term we have written here, minus a power n plus 1 by 2 into b power 1 by 2. For what purpose means we will come to know the next step. Then here a power 1 by 2 into b power n plus 1 by 2 minus b power n plus 1. The same way how we have written for a, the same thing we have written for b also. B power n plus 1 by 2 into b power 1 by 2. Then the purpose of doing is this one, a power n plus 1 by 2 is common. A power n plus 1 by 2 here is there, a power n plus 1 by 2 is there here. So that we can take it out, a power n plus 1 by 2. In the first term a power 1 by 2 is there, balance, and in the second term b power 1 by 2 is there, minus. Here also same thing, b power 1 plus 1 by 2 is common. If you take out, in the first term there is a power 1 by 2 minus, in the second term there is b power 1 by 2 balance. That means here the left hand side, right hand side, when you check, these two terms are common. We can cancel it. That means a power n plus 1 by 2 is equal to b power n plus 1 by 2 is there. Then here what we can do is a power n plus 1 by 2, this one we can bring to the left side. That means divided by b power n plus 1 by 2 is equal to 1. Right side nothing is there, this came to the denominator here, so balance is 1. That means a by b the whole power n plus 1 by 2. A by b, the power is same here, both numerator and denominator, so we can take it out as common outside, common power. So a by b the whole power n plus 1 by 2 is equal to, here 1. This 1 we can change as base, same base with the a by b power 0. Any quantity power 0 is 1. So a by b, the same base we put a by b the whole power 0. That means now the bases are same, the powers also will be same. That means n plus 1 by 2 is equal to 0. That means n is equal to minus 1 by 2. So here we are asked to find out the value of n. Here the value of n is minus 1 by 2. Next we shall discuss question number 28. The sum of two numbers is 6 times their geometric mean. Show that the numbers are in the ratio 3 plus 2 root 2 is to 3 minus 2 root 2. Here the sum of two numbers is 6 times their geometric mean. So sum of two numbers is 6 times the geometric mean. That is the condition given. So show that the numbers, the required numbers are in the ratio 3 plus 2 root 2 is to 3 minus 2 root 2. So geometric mean of a and b, two numbers a and b, if you consider, their geometric mean is a root of ab. The sum of two numbers a and b is 6 times of their geometric mean. Now we have assumed two numbers a and b. As per our condition, given condition, sum of two numbers, that means a plus b, is 6 times, that means 6 into their gm is root of ab. So a plus b is equal to 6 into root of ab, that is what it is written. Sum is 6 times its geometric mean. So a plus b is equal to this 6 into root of ab, we can write it as 3 into 2. 6 we can split as 3 into 2 root ab. Then here a plus b, this 2 root ab we can bring to the left side, to the denominator. 2 root ab equal to 3 divided by 1. Now there is a rule we are going to study. For componendo and dividendo we will tell. This what we are going to do next operation is componendo and dividendo. That means if a by b is equal to c by d, means these two fractions are equal, means what we can do is their a plus b. Okay, a plus b means denominator we are taking and adding with the numerator. That means a plus b divided by a minus b, means denominator we are subtracting from the numerator. So a plus b by a minus b. The same operation here also we can do. C plus d by c minus d. So a plus b by a minus b is equal to c plus d by c minus d. Then the ratio remains the same. This ratio we can change into this format, but both will be same. That is what component and dividend. So what we can do is here a plus b. A plus b means the denominator we are taking and adding. So when we do it, a plus b, that is our numerator, plus the denominator, that is 2 root ab. Then what is next is a minus b. A minus b means here a is a plus b. Okay, numerator. So a plus b minus b. Minus b means the denominator, minus 2 root ab equal to c plus d. C is numerator, d is denominator. So denominator take and add it to the numerator. So 1 plus 1 will take to the numerator, means 3 plus 1 divided by numerator is 3 minus the denominator, 3 minus 1. So here this is in the form a square plus b square plus 2ab. We can make it this into that format. So here a we can write it as a root a square, plus b we can make it as a root b square. What is root a square? Root a square is a, root b square is b. Then so when we change this one, a as root a square plus b as root b square, then this one we can keep as it is, 2 into root a into root b. Now this is in the form a plus b the whole square, a square plus b square plus 2ab. Denominator also same thing, there is a minus sign. 3 plus 1 is 4 divided by 3 minus 1 is 2. Now this form, as I said before, a plus b the whole square, a is root a the whole, then b is root b. So root a plus root b the whole square by here is root a minus root b the whole square, because there is a minus sign. Then 4 divided by 2, when we cancel, 2 will be coming. So 2 divided by 1 we are getting. Then root a plus root b divided by root a minus root b is root 2 by 1. So here what we can do is taking the square root. Taking the square root means here a plus b the whole square root is root a plus root b. Root a minus root b square root is, sorry, here root a minus root b the whole square is there. Square, when you are taking the square root, the squares will be going. So root a plus root b by root a minus root b. Here there is no squares, because of that square root as it is will be coming. Square root 2, and here square root of 1 is 1 itself. What we have done is here taking square root. Then again one more time we are taking component and dividend. So what we can do, a plus b means the denominator we are taking, we are adding with the numerator, means root a plus root b plus the denominator, that means root a minus root b, that is written. Then numerator we are taking root a plus root b, subtracting the denominator minus root a minus root b, equal to, here also the same thing, root 2, then plus 1, denominator we are taking and adding, then root 2 minus 1, minus 1 means denominator we are subtracting from the numerator. Then here when we remove the brackets, it is quite clear, there are some opposite sign symbols are there, plus root b minus root b we can cancel, here plus root a minus root a we can cancel. After that we will be having root a plus root a, that is 2 root a, root b minus into minus plus root b, that is 2 root b, equal to root 2 plus 1 by root 2 minus 1. Then here also 2 we can cancel, there is numerator 2, denominator also 2. That means root a by root b is equal to root 2 plus 1 divided by root 2 minus 1. Again we can go for taking square, because we need a by b only, the ratio, so that the numbers are in the ratio. Our numbers are a and b, so we have to take square. That means a by b is equal to, square root is gone. Then here a plus b the whole square, root 2 plus 1 the whole square means a plus b the whole square. What is a plus b the whole square? A square, that is root 2 square, root 2 square is 2, plus b square is 1 square, 1 square is 1. 2ab, that means 2 into 1 into root 2, that is 2 root 2. Same thing only here also, denominator here root squaring means this root is gone. Then here a minus b the whole square, a minus b the whole square means a square, that means root 2 square is 2, plus b square is 1 square, 1 square is 1, minus 2ab, minus 2 into root 2 into 1, that means minus 2 root 2. Then here 2 plus 1 is 3 plus 2 root 2 divided by, here also 2 plus 1 is 3 minus 2 root 2. You see there the ratio, required ratio 3 plus 2 root 2 is to 3 minus 2 root 2. So a by b we have got as this ratio. So hence proved. Next we shall discuss the 29th question. If a and g be the arithmetic mean and geometric mean respectively between two positive numbers, prove that the numbers are a plus or minus a root of a plus g into a minus g. Here a and g be the arithmetic mean and geometric mean between two positive numbers. We need to prove this statement. Prove that the numbers are this one. Okay. Here let the two quantities a and b. Here two quantities we have taken, that is a and b. A is greater than b, then a is equal to the arithmetic mean, that is a plus b by 2. Then a plus b is equal to 2 into a, that means cross multiplication, equation number 1. Then g, geometric mean, that is the representation is given to us. G is the geometric mean. Geometric mean between two numbers a and b is a root of ab. Then ab is equal to, when we are squaring, we don't want the square root, so when we are squaring, g square is equal to root ab square is ab. Equation number 2 we can make. So we know that a minus b the whole square is equal to a plus b the whole square minus 4ab. This is the identity, just by heart it if you don't know. A minus b the whole square is equal to a plus b the whole square minus 4ab. Then putting the values 1 and 2, from 1 and 2, here a minus b the whole square is equal to a plus b. A plus b is 2a, so 2a the whole square, 2a the whole square is 4a square. Then minus 4ab, minus 4ab means here ab is g square, 4ab means 4g square, minus 4g square. What we have done is a plus b value we have put, that is 2a the whole square, 2a the whole square is 4a square, minus 4ab, 4 into ab is g square, so 4g square. In these two terms there is 4 is common, take out, then a square minus g square will be coming. A square minus g square. Okay, this there is a square outside, this square is not outside actually, this is inside. A square minus g square. Then taking square root, because we are having a minus b the whole square equal to 4 into a square minus g square. Taking square root means what we are getting is a minus b the whole square root is square and square root cancelled, that means a minus b will be coming. Square root of 4 is 2 into, here there is no squares, common squares are not there, so entire term will be under square root, so square root of a square minus g square. Once again, square root of a minus b the whole square is a minus b, square root of 4 is 2, square root of a square minus g square as it is. That is equation number 3. Then adding 1 and 3, what we are doing is, this is equation number 1, this is equation number 3, because here a plus b, here a minus b. So when we are adding a plus a, that is 2a, then plus b minus b, that is cancelled, then 2a plus 2 into root of a square minus g square. Once again what we are doing is adding 1 and 3 means, this is a in equation number 1, here this is a plus a is 2a, this is plus b and this is minus b, cancelled. and here 2a plus 2 into root of a square minus b square. Then everywhere here again adding 1 and 3. Adding 1 and 3 means here we are getting this same statement only. If it is repeated, but actually not necessary, the same statement only it is written here. Then dividing by 2, when we check here, there is a common term is there. 2 here, 2 is there, here 2 is there, here 2 is there. We can cancel it. That means 2 going means a balance, here 2 going means capital A balance, plus here 2 going means root of a square minus g square is there. This is a square minus b square format. A square minus b square is a plus b into a minus b. That means a plus g into a minus g. Then similarly, what we have done is we have just added equation number 1 and 3. Now if you subtract equation number 3 and 1, if you subtract equation number 3 and 1, what we'll be getting is b will get. That is b is equal to a minus root of a plus g into a minus g. So similarly we can put on right, no need to show like this. So when we are subtracting 3 and 1, okay, 3 and 1 when we subtract, we will be getting b is equal to a minus root of a plus g into a minus g. Not necessary to do the calculation. From here we can write, because we want a plus or minus. That is what the values of the numbers are. A and b are these two numbers. So already plus we have got, then surely the b term will be minus. By using that similarity condition, we can just write. So this is equation number 5. We can put from 4 and 5 means 4 is a value, 5 is b value. We can come to the conclusion is a plus or minus root of a plus g into a minus g. These are our numbers. Next we shall discuss question number 30. There are some practical questions, daily life questions. The number of bacteria in a certain culture doubles every hour. If there were 30 bacteria present in the culture originally, how many bacteria will be present at the end of second hour, fourth hour and nth hour? The number of bacteria in a certain culture doubles every hour. Doubles means it becomes what it was there first, the same quantity again it will increase after 1 hour. So if there were 30 bacteria present in the culture originally. So here originally at t is equal to 0. T is equal to 0 means time, when the time considered as 0 hours, the number of bacteria is 30 and it doubles everywhere. That is what condition. At first means at 0 hours, when the time is 0, initial time, when the time is 0, the number of bacteria is 30. Then the number of bacteria at the end of first, second and third hours. First hour means it becomes 30 into 2, means it doubles, 30 into 2, that is 60. Then next it becomes 120, 60 again doubles means 120. Then 120 we have to form a geometry progression. 120 how we can make is 30 into 2 square. 2 square means 4 into 30, 120. Next this 120 becomes 240. Doubles, it means 240. How can we write 240? By connecting 30 and 2 square, that is 30 into 2 cube. And it goes on like this. So we have, our aim is to form a geometric progression. That is what our aim. Once again, how we have formed the geometric progression, let's check. At t is equal to 0 means 0 hour, the initial count was 30. And first hour means at the end of first hour means after 1 hour it doubles. Double means 30 into 2, it becomes 60. And again after 1 hour 60 becomes 120. And 120 becomes 240. So if you want, I will write and show you that. Here this term becomes 120, okay, and this one is actually 240. Double means 240. But this 120, 240 and all, if you write and give, we don't form a geometric sequence. We don't find the rule. So 30 into 2, then we will write 30 into 2 square. 2 square means 4 into 30 is 120. Then 30 into 2 cube and so on. Then which form a GP. The number of bacteria at the end of, here we have to write at the end of second hour, fourth hour and nth hour. So at the end of second hour means we know that it is, this is the one, 30 into 2 square. That means 120. That we have multiplied and kept here. At the end of fourth hour means 30 into, here now we know the rule, fourth hour, the time is on the power of 2. So 2 power 4. 2 power 4 means 480 will be coming. 30 into 2 power 4. 2 power 4 if you multiply and check, 2 into 2 into 2 into 2. That is 2 into 2 into 2 into 2. That means we will be coming as, we will getting as 2 into 2 is 4. 4 into 4 is 16. Okay, we will be getting as 16. Then 16 into 30. 16 into 30 only we are getting as, when we multiply, we are getting as 480. This is what the answer. Okay. Then next is nth hour means we know the general rule now. 30 into 2 power, here is the time, 2 power n. Nth hour, here fourth hour means 2 power 4, here is the time. Here second hour means 30 into 2 power 2, here is the time. So likewise here nth hour means this is our time. So 2 power n, 30 into 2 power n is the general form. Next we shall discuss question number 31. What will rupees 500 amount to in 10 years after its deposit in a bank which pays annual interest at the rate of 10% compounded annually? Suppose you are depositing rupees 500. After 10 years, how much amount you will get? That is what the question. If the bank is paying 10% interest compounded annually, that is what the question. You are depositing 500. Bank is paying 10% compound interest. After 10 years, how much amount you will get? That is what the question. Here, the initial or the basic concept you should understand is the amount will be calculated at the beginning of every, means at the end of each year. That is the amount. Amount will be calculated. The principal value. Principal value means the amount which you have deposited initially. That is, here it is 500. For the first year, it's 500 rupees. And its interest, that means I, P plus I we call. So amount will be calculated by using the formula P plus I. Here I is the simple interest, okay. Formula is PRT by 100. So amount at the end of first year is, here I already told you, PRT by 100. By using this one we will be calculating the interest I, then we will be adding with the P. P means here at the beginning of first year it is 500. So 500 plus, as I said before, this is our interest. P plus I. P is 500. Our interest is 500 plus 10. 500 into 10 into 1 by 100. Then here 500 is common. You can see here also 500 is there. Here also 500 is there. So I am taking 500 common out. That means in the first term there is one balance. Means this 500 is outside. 1 plus here. When you check in the denominator, there is 1 0, we can cancel. Here you can see 1 0. So 1 into 1 is 1. So 1 into 1 is 1 by 10. 1 by 10 is 0.1. So how we have got is, in these two terms, 500 is common, that we have taken 500 outside. And 500 going out means here one balance, that is written, plus here 500 is outside. 1 into 1 is 1 by 10. 1 by 10 is 0.1. This is what we have calculated. That is equal to rupees 500 into 1 plus 0.1, that is 1.1. This is what at the end of first year. Then amount at the end of second year. Amount at the end of second year means here our principal amount is changed, because at the end of first year we have got this much. So that will be the principal amount for the second year. So initially 500 rupees was there. That 500 rupees after 1 year it is amount to this amount, this money. This one will be considered as the principal amount for the second year. 500 into 1.1 plus, again the same formula, PRT by 100. But what is our P? P is 500 into 1.1. Rate of interest is same, 10. Time means it is for only 1 year, as before. Here also 1 year only, so 1 divided by 100. Then here also 500 into 1.1 is common. You see here 500 into 1.1, 500 into 1.1, that is common. Then in the first time 500 into 1.1 is outside, one balance. And here also 500 into 1.1 is outside. 10, here also 10 and 0. Numerator there is 1 0. Here denominator 1 0, we can cancel. As before, it will be 1 into 1 is 1 by 10, that is 0.1. That means 500, that is this 500. Here when we add 1 plus 0.1, we will be getting 1.1. 1.1, previously there was 1.1. So 1.1 into 1.1, 1.1 square. 500 into 1.1 square. Similarly, amount at the end of third year, you see here amount at the end of first year is 500 into 1.1. Second year means 500 into 1.1 square. Number of year is here. That means third year means 500 into 1.1 the whole cube, and so on. So here actually after 10 year how much we have to find out. So it is easy if you form a GP like this. If you multiply and keep the answer alone means it won't be able to find out easily. Now it is easy for us to find out because we know the rule now. So 500 into 1.1, 500 into 1.1 square, 500 into 1.1 cube. This is what the amount for first year, second year, third year, and so on. So they form a GP. So required amount at the end of 10 years means n we have to replace and put 10. That's all. That is 500 into 1.1 the whole power 10. Move on to the 32nd question. If AM and GM of roots of quadratic equation are 8 and 5 respectively, then obtain the quadratic equation. If AM and GM of roots of a quadratic equation are 8 and 5, so then obtain the quadratic equation. Very simple question this is, and it is important also. Let the roots of the quadratic equation be alpha and beta. Okay, and AM is equal to 8, and AM 8 means we know that arithmetic mean formula alpha plus beta by 2. Here alpha and beta are the roots we have taken. Alpha plus beta, previously A and B, if we take A plus B by 2 will be getting. So here alpha plus beta by 2 is equal to 8. That means alpha plus beta is equal to 16. Then GM is equal to 5. GM 5 means we know that it is a root of AB previously. Now here root of alpha beta. Root of alpha beta is equal to 5. When you square it here, we'll be getting alpha beta is equal to 5 square. 5 square is 25. Now, required quadratic equation is, we need to form a quadratic equation. In class 10 we have learned sum of the roots is 16 and the product of the root is 25. So we know the formula. If the sum of the root and the product of the roots are there, means quadratic equation we know how to make. That is x square minus sx plus p is equal to 0. X square minus sum into x plus product is equal to 0. That means x square minus sum, that means alpha plus beta into x plus alpha beta equal to 0. We know the values. X square minus alpha plus beta is 16, alpha beta is 25 equal to 0. So this is the required quadratic equation. X square minus 16x plus 25 equal to 0. Dear students, today we have completed exercise 9.3. I request all the students to go through the entire exercises and concepts from the chapter, sequences and series, and get ready for solving the multiple choice questions. While solving, if you have any doubt, please mark it and keep. We will discuss it during the discussion session. Thank you for watching.